Hello geometry students, today we are going to start our chapter 10.1. That's on page number 281. That's on page number 281 in your Big Idea Student Journal. So before we start 10.1, we need to know about basic definitions. So we are going to learn about lines and segments that intersects circle. So this chapter is all about learning about lines and segments that intersects the different circles. So very first definition here, we're going to learn about radius. So basically it's all about circle. So radius is, when you talk about a circle, it's a segment whose endpoints are the center of any point on a circle. So radius is, in this case, this is the radius. You can see this is the radius which starts from the center and ends at the circle. This is your radius. All right. Next definition is chord. So let's move to chord. So what is chord? It's again a segment, but the endpoints are on circle. The endpoints are going to be they're on the circle. So this is the chord, and this one, because it's starting from circle and ending at circle. All right. But you may be thinking, can a diameter is a chord? Yeah, diameter is also a chord. So let me share, where is it? It's a diameter. That's a diameter. So the line has to start from the circle and should end at the circle. So that's going to be chord, and longest chord is the diameter. It is this one, all right, that contains the center of the circle. So how do we know the diameter that passes through the center? That's a chord, all right. Then secant. What is secant? Secant is actually a line that intersects the circle in 2 points. So whenever you see secant, that's not only a chord that will just intersect. You will see an intersection point here in the bottom. So they just cross it. It is slice it. It can pass through from any section of the circle. So that's your secant. And then another definition is about tangent. Tangent is what? It's a line in a plane of circle that intersects the circle in exactly 1 point. So it's basically, you can say tangent, it touches the circle at just 1 point. That's a tangent, given tangent at point B. So this line is a tangent because it's touching at 1 point. So when it touches the tangent, you can think about that it touches at 1 point. It touches at just 1 point. So that's why it's tangent. And the secant, it is like intersecting, it's slicing, it's just working like a knife. And here the point where it touches the circle, the tangent, that's called point of tangency. And here tangent ray AB is the tangent segment AB. So if you're talking about tangent ray AB, this thing is the tangent segment. You name it as AB. Segment is named as like that. All right. So one thing here you have to keep in mind, you may get confused when you talk about chord. Chord is just starting from the circle, ending at here. So that's a chord. But anything. So if I'm just talking about, this is also a chord. All right. If I take this circle, this is a chord. So the diameter is the longest chord. Okay. That contains the center of the circle, and this is your center in the middle. That's the center. Okay. Any question? Let me know. Let's move to the next part. Now we have to understand about coplanar circles. So coplanar, means they lie on the same plane. So if they're lying on the same plane, they're called coplanar. And in a plane, 2 circles can intersect. When it's something like when there are 2 circles, there can be different intersection points. All right. The intersection points it can be 2 points. They can meet at 2 points, or they can meet at 1 point, or they cannot even meet at all. So there can be three situations. They can meet at 2 points, they can meet at 1 point, they can meet at 0 points. And coplanar circles that intersect in 1 point are called tangent circles, where they meet at just 1 point. This is the case where it's going to be the tangent circle you will see. And coplanar circle that have the common center are called concentric circles. So concentric and all these things I'm going to show you one by one. So first case is here. You can see your very first case is this one, where the point of intersection, you have 2 points of intersection. So you see that they're meeting it here, 2 points of intersection. These are 2 points of intersection, and it could be the center of this one, it could be the center. You see they don't have the same center. So that's the first case. Other case could be when they have just 1 point of intersection. They're just meeting at 1 point. You see that in this case this is 1 point and here it is 1 point. When they meet at just 1 point, in that case you will have a tangent circle. So the circles here, they're going to be called this one, and the same time this one, they're the tangent circle because they're just meeting at 1 point. And here same here, this one and this one. You will see there you will have a tangent there. So because you can see a tangent there. So let me write down that. You would see tangents. All right. And other cases when you have no points of intersection, you see they're not meeting at all. All right. So here in this case, no points of intersection. We see for this case they're not touching. They're not touching at all. So it's called no point of intersection. And in this case also we see they're not touching at all. But the last case could be, we call that concentric circles. Concentric circle, because their center is same. For smaller and for the bigger, they have the same center. So it's called concentric circle. And then afterwards we have another concept that here I talked about when the line segment that is tangent to two coplanar circle is called common tangent. So here it's not only the tangent, it's called common tangent because it's common to both. Common tangent to both. And common internal tangent intersects the segment that joins the center of the two circles. So it is this one. All right, internal tangent, this is the case. It is this one. If we have a circle here, this is tangent, I have another circle. So if I connect my centers here, so this is called common internal tangent. Common internal tangent. All right. And after that, we have another definition, common external tangent. Common external tangent, they do not intersect the segment that joins the center of the two circles. So that's going to be a case where there is one circle, another circle. This is the center, this is the center for the bigger one, and that's the tangent. They're not, when you connect the centers, this is the center for bigger one, this is the center for smaller one. When you connect them, then they're not at all intersected by the common external tangent. So here, this is your common external tangent. All right, so that you can see here, this one and this one are described here in this picture where just one point of intersection. I hope you get it. In next video I'm going to do more problems from this chapter 10, and till then stay healthy. Bye. So we are going to use the tangents to learn two more theorems from this chapter. So first theorem is tangent line to circle theorems. So we're going to learn about how the tangent to a circle, what is the thing we can say about. So a line is tangent to a circle. How can you decide some line is a tangent to a circle? If and only if the line is perpendicular. If the line is not perpendicular to the radius of the circle at its endpoint of the circle, then we don't call it tangent. So in this case, this is the tangent. All right, so let me use other color. This is the tangent, and this could be tangent on if and only if this is the radius, if it is making 90-degree angle. If it is not making 90-degree angle, suppose your circle is like this and I say this is the radius and I say there is a line and this is not 90. If this is not 90 degrees, then we don't call it then this is not a tangent. Alright, so keep in mind it has to be a perpendicular, or you can simply say the angle between the tangent and the radius is 90 degrees. So we can just summarize that. If M is the tangent to circle Q, then this is the way how they write the name of a circle, by its center. So if the center is Q, so we read it as circle Q. Alright, if and only if M is perpendicular to QP, the tangent has to be perpendicular to QP. So we can say that tangent is perpendicular to radius. By looking at the figure, if it is a tangent, then it's going to be perpendicular to radius, and perpendicular means it makes 90-degree angle. Alright, then there is another theorem, that is we have external tangent theorem, congruence theorem. What if we, instead the first one, when we have just one tangent here, what if we have two tangents? What can we say? So if we have tangent segments from a common external point like this is a common external point, and then from this point we see there are two tangents. This is a tangent, this is a tangent. Then what is the theorem? According to the theorem, external tangent congruence theorem, the tangents are going to be congruent. This is going to be congruent to this. So we can say SR and ST are congruent, and SR and ST, they're going to be their tangent segments and they're going to be congruent. Alright, so means if you draw two tangents from outside point to a circle, so if this is your circle, if I'm drawing two tangents from, if a point here and I draw a tangent, here, sorry, then it's going to be, this is going to be congruent to this. And also keep in mind, if this is a center and if this is a tangent, then the angle between the radius and tangent here and here is going to be 90. So this is the combination of both at point 1 here and 10.2. Just explained it so that you can apply in the future problems. Till then, stay safe. Thank you. Bye.